Good morning. All right. So what we're going to do today is jump back to 10.1 and 10.2. I had skipped over all the word problems, so that's what we're going to focus on today. I wanted to make sure we got through all the solving part first for both 2 variable and 3 variable. So now that we've done that, now I'm going to go back to 10.1 and do the word problems with the 2 variable ones, and then we'll look at 10.2, just the 1 word problem there with 3 variables. Okay, so that's the plan for today. I'm also going to show you in the calculator how we can set these up to be able to solve, because on the word problems on the test, whatever method you use to solve is perfectly fine. So as long as you can get the setup, if it's graphable, then graph it. But especially with the 3 variable ones, you're not going to be able to do that. And so I'm going to show you in the calculator how we can actually use something there to solve these also. Okay, so that's the plan for today. Then tomorrow we'll do as much of 10.8 and 10.9 as we can. I'm at least going to do some examples from both, right, so that you're able to do the homework and have enough to be able to finish the test. And then, like I said, next week, Monday, Tuesday, we'll still hold class time to go through the exam review. So that's the plan for next Monday and Tuesday. Again, not a requirement, right? You don't have to be there. If you even want to take your exam before those review sessions, that's perfectly fine. But if you want that review before you take your final exam next week, we will do that on Monday and Tuesday. Okay, so again, don't forget, test 5 is due by midnight Friday night. Again, not in respondus. Take your time, do it whenever this week. Use your notes, your book, whatever resources you need, but make sure you get that submitted on time. And then also the 10.1 to 10.3 homework is due by midnight also on Friday. Okay, any questions, comments, concerns before we get started today? Final exam is 10 questions, okay? So it'll be basically 2 questions from each unit. It's kind of how you can think about it. But again, on Monday and Tuesday of next week, I'm going to try to focus in on the exam review, the types of questions you probably want to work on. So that's why those 2 sessions will be useful if you want to come to those, okay? Any other questions? Because I know the exam review itself is 30 some odd questions, right? But yeah, the final exam itself will only be 10. Okay, so 2-hour window, just like your other test, and 10 questions. All right, so if you think of anything else, feel free to email me, right? I'll be responding to email throughout the afternoon, or just ask me during class if you think of anything that comes up, okay? All right, so let's take a look. Again, this is 10.1 now. We're going back to that section, example 7. So we've got a woman that rows a boat upstream from one point on a river to another point that's 4 miles away in an hour and a half. The return trip traveling with the current takes 45 minutes. We want to know how fast does she row relative to the water and at what speed is the current flowing. So the first thing I notice here based off of that question is I have 2 different things that I'm trying to solve for. I want to know how fast is she rowing and how fast is the current flowing. So that tells me I'm going to need 2 different variables for this problem. What variables would you like to use? So we can use whatever letters we want. So what do you want to use here? X and Y. So creative, right? So X equals and Y equals. All right. So if we use X, right, what could X represent in this case based off of what we're trying to solve for? Okay, the speed of the woman, right? So we'll say speed of woman rowing. And so then what would our Y value represent in this case? The speed of the water. Good. Okay, so speed of the water or speed of the current, right? However you want to define that. Okay, we're looking for 2 different speeds, right? The speed that she's rowing and the speed that the water is flowing. Now we've got to think about how we're going to set up equations to solve for those 2 variables. Well, if there's 2 variables, we're going to need 2 equations. So we've got to set up a system this time. Think about what we know here. So we're told the distance, right, that she's going 4 miles. We're told the time, and we're looking for her speed. Do we know any equation right? Any formula that would relate those things together. So distance, time, and speed. Okay, so it's almost a slope, right? But the thing is, we're not going to actually need to write a linear equation from this. So I don't really want to think of it that way, right? So I just want a formula that relates distance, time, and speed together. Good, right? So we know that speed is distance over time, right? Something like miles per hour would be a distance over a time. So we can write this as S equals D divided by T. Those are the three things we're working with. That's the formula that relates those three things together. Now, in this case, just to make our equations easier, I'm going to multiply both sides here by T, right? And just get this as S times T is equal to D, right? So speed times time equals distance now. Now let's think about how we can actually write our equations based off of that formula. Well, in this case, we know that she's rowing at a certain speed, but the current is either helping her or hurting her depending on the direction that she's going, right? So on that first trip, right, if she's going upstream and it takes her an hour and a half, is the stream, the current, working against her or with her? It's against her, right? And that's why it takes longer to go that direction. So basically, what we're going to do is we're going to take her speed, which is x, and we're going to subtract the speed of the current because it's actually slowing her down this time. This right here is the speed now. So her speed minus the speed of the current is the total speed. Now we need to multiply that by the time. Well, what's our time going to be this time? So for that trip where it's taking her x minus y, where this current is hurting her, slowing her down, okay? So we want to do this probably in hours, just so we end up with miles per hour as our units in the end. You could do either, right? So you could convert everything to minutes if you really want to. I think hours is going to be easier in this case. So how many hours did it take her on that trip? 1.5, right? It's an hour and a half. So we'll do 1.5 hours as her time. And then we want to set that equal to the distance. And so what's the distance for that trip? 4 miles, right? So we're going to set that equal to 4. So again, this is our time. This right here is the distance. And so we have speed times time equals distance, right? And that's the upstream trip. Now we need a second equation in the other direction. What is the speed going to be when she's going in the other direction? Good. In this case, right, downstream, the current is helping her, it's speeding her up. So we're going to take her speed plus the speed of the current times what's the time for that trip going to be? Good. 45 minutes is the same thing as 3/4 of an hour. So 0.75 hours is what we're going to convert that to. So we get 0.75 as our time. And then what's the distance going to be for that trip? 4. Good. So same distance, both directions. So that's going to be 4 again. Any questions about how I got those two equations here? right, so now, before we can solve this, we need to distribute first, right? So I'm going to distribute the 1.5 in the first equation, distribute the 0.75 in the other equation. Then my system becomes 1.5x minus 1.5y equals 4. And then down here, we're going to have 0.75x plus 0.75y also equals 4. So that's the system we're trying to solve now. Now, what I'm going to show you is how we can actually use our calculators to solve this system without actually using graphing, right? Because you could graph this one, right? There's no doubt you could put it in Desmos, find the points of intersection. But I want to show you how we could actually do this using our calculators because this is a good strategy, especially in the 3 variable ones, and we'll do it there also. First thing we're going to do is create what we call a matrix. Right? So if we look at this system right here, first thing I need to figure out is what's the total number of variables and constants that we have? Okay, well, I've got an x, I've got a y, and then I've got a constant on the other side. So in total now, there are 3 variables and constants, x, y, and the constant. Then I'm going to look at how many equations we have. Well, in this case, we have 2 equations. That's what I'm going to put over here. What that tells us now are the dimensions of a matrix that we can put into the calculator. And we always do this as rows by columns. Rows run horizontally, columns run vertically. So this has 2 rows and 3 columns. So we would call this a 2 by 3 matrix. Okay. So the number of equations tells you the number of rows, horizontal. The number of variables and constants tells you the number of columns, which are the verticals. Now I'm going to write a matrix, right? And if you've never seen matrices before, we basically just use brackets for our matrices. We don't need the variables, though. We only need the numbers. So if I look at this first equation, I'm only going to list out whatever the coefficients are and the constants, not the x's and y's. So my coefficients in that first equation are 1.5, so that's my first entry here. Negative 1.5 is my next coefficient, and then 4 is my constant. So that gives me my 3 columns now. Then the next row is just going to be the coefficients and constants from the other equation. So that's going to be 0.75. We have another positive 0.75. And then 4 is our constant again. So again, that's a 2 by 3 matrix, 2 rows, 3 columns. Those would be our entries now because we just ignore the x's and y's. But remember now, what this tells us is our x is represented in this column, our y is represented in that column, and then our constant terms are represented in that column down there. Any questions about just writing the matrix for that system now? All right, so the next thing I'm going to do now is I'm actually going to enter that matrix into my calculator. Let me switch my screen here so we can look at that together. All right, so I'm using a TI-84 Plus. If you've got a TI-83, it's still very similar. Your buttons might be in different locations. So to get to my matrix, right, once I turn my calculator on, my matrix key is actually right here above the x to the negative 1. It says matrix. So I have to press the second key first and then x to the negative 1 to get into my matrix menu. The TI-83s have a matrix key, so you don't have to do the second key. You just press matrix in that case. Now, once we're in that menu, to be able to input this matrix, we're actually going to go all the way over to the edit menu over here now. So go to your matrix, go over to edit. Then I'm just going to select any one of my matrices. I'm just going to put it in A here. So I'm going to press enter to select matrix A. And now we need our dimensions, right? So what did we say the dimensions of our matrix are going to be for this one? 2 by 3, good. So I'm going to change my dimensions here to a 2 by 3 matrix. And you can see once you do that, it should update your screen to give you 2 rows and 3 columns. Now I'm just going to put all my entries in from that matrix that we just wrote. So this is going to be 1.5. If I press enter, it automatically moves to the right, so then I can just keep going. Negative 1.5, enter, and then 4, enter. So that takes care of the first row. Then my second row, we had 0.75, 0.75, and 4. Any questions about getting that into the calculator? Okay, now this next step is important. We're going to go back to our home screen. Okay, so make sure you press second and quit, which is right here above the mode key next to second. Get back to your home screen now. Now we're going to go back into our matrix menu. Okay, so second, matrix. And what I'm going to do now is I'm going to go over to my math column, and I'm going to scroll all the way down to what's letter B in my calculator. It says RREF. Okay, so there's one right above it that says REF. Make sure you're going all the way down to the one that has 2 R's, RREF. What that stands for is reduced row echelon form. And when we get our answer, I'll show you what that looks like. Okay, but just know that that's what we're doing now. Okay, so I'm going to choose RREF. And now it's asking me, well, what matrix do you want to do the reduced row echelon form of? So again, I have to go back to my matrix menu. And I'm going to select under names now the matrix that we just put in there. So wherever you put that matrix, again, I put mine in A. So I'm going to select matrix A. And then we just have to press enter. And it's going to tell us what the reduced row echelon form is of that matrix. Okay. So I'm just going to copy that down now on my slides, and then we'll go back to that. So we get 1, 0, 4, and then 0, 1. 1.3 repeating, same thing as 4/3 or 1 1/3. So however you want to write that is fine. Okay, so I'm just going to write it as 4/3 for right now. And you can see if you just convert to a fraction there, it'll do that for you also. All right, so that's what we get for our matrix, right? So again, now I'm going to go back to my slides. Okay, so there's the matrix we got. So what we have to think about now is what those columns actually represent. So what did we say the first column represents here? X, right? So I know that this is my X column. My second column then is Y, and then down here, this is going to give us our constants. So if we read off what that first row is now, we have 1x, we have 0 y's, and our constant is 4. Or in other words, 1x is equal to 4. Then if we look at the second row, we have 0 x's, we have 1 y, and our constant is 4/3, or again, 1 y is equal to 4/3. There's our solution, right? So that is our X and Y value. That's the solution to this system now. And so now we know that her speed, right, the rowing speed is going to be 4 miles per hour. And we know that the speed of the current is 1.3 repeating, or 4/3 miles per hour. And that would be our solution now to this problem. Now again, those are the same solutions that you would get if you were to solve this using elimination, or if you were to graph it, whatever you want to use, right? Because you can use whatever method you want. Okay, but this is another method now using matrices and reduced row echelon form that will also give us our solutions. Any questions on that one now? So in Desmos, you would, it's in terms of matrices, not that I know of. I know Desmos is adding a lot of functionality. Um, I haven't had a chance to see if you can do, I know it will allow you to input matrices, not in the graphing part, but they have a separate calculator that will do matrices, because I know one of our linear algebra teachers has been using it. I assume it might do reduced row echelon form, but I haven't had a chance to play with it enough to make sure. Okay. So for this one with two variables, it's going to be better just to graph it and find the point of intersection, right? Where the matrices are very useful is those three variable systems that you can't graph, and maybe the other methods are a little bit trickier, right? And so then using matrices is extremely helpful in those cases. Yeah, so this one personally, I would probably just graph this one, right? Because it's probably quicker. But yeah, with the three variable ones, the elimination method's a little trickier. That's when the matrices are easier. Okay. Like I said, right, on your test, numbers 2 and 3, the word problems, once you get the setup for those two, you can solve it however you want, right? So use graphing if it works, that's fine by me. Or if you want to use matrices there, that's fine too, right? You don't actually have to algebraically once you actually get the setup for those. Not so much. The only time that I would say that these come up is Calc 2 when you do partial fractions for integrals. Then matrices are useful in finding your values for your partial fractions because you're going to use systems of equations to find those values. And that's a section in our book too. So if you look at 10.7, that's partial fractions. That's what you would use it for. The reason I typically don't teach partial fractions in our class is because by the time you get to Calc 2, most people have forgotten it anyway, so we usually have to reteach it. So I usually just wait and teach it there. Okay. Any other questions there? All right. So let's take a look at this one now. So we have a mixture problem. So a vintner fortifies wine that contains 10% alcohol by adding 70% alcohol solution to it. The resulting mixture has an alcoholic strength of 16% and fills 1,000 1-liter bottles. So we want to know how many liters of that should be wine, sorry, and of the alcohol solution does the vintner use? All right, so again, my first step, I'm always looking to see what am I trying to solve for so I can define those variables. How many variables do we need this time? 2, right? We're looking for how many liters of wine and how much alcohol solution, right? So what variables do you want to use this time? Okay, x and y again is fine. So x equals, y equals. So in this case, I'm going to let x equal the liters of wine. And then I'm going to let y equal the liters of alcohol solution. Okay, so those are the two things we're looking for this time. Now we've got to think about how we can set up equations for this one. So what's one thing we know that we could use to write an equation here? All right, so we know there's 1,000 total liters, right? So I know I'm looking for the liters of wine and the liters of alcohol solution, but I also know that my total amount here is 1,000 1-liter bottles, so we have 1,000 total liters. So how could I write an equation for that? Perfect, right? So the liters of wine plus the liters of alcohol solution should equal 1,000 liters total, right? So that's one equation for this one. Now we need our second equation, right? And so I can go ahead and tell you those percentages are going to come into play now. So we got to think about how we can use those percentages to write an equation now that's going to help us to solve for x and y. What do you think that equation might look like? So what do we know about the wine? What's the concentration of alcohol in the wine? 10%, right? So what I can say is I know that I'm going to take 10% of the liters of my wine, right? Because that's the percentage there. So we have a 10% solution for our wine. What about the alcohol solution? 70%, right? And we're adding that to it. So it's plus 70% or however much alcohol solution we're adding, right? So we have 10% for all of our wine, 70% for all of our alcohol solution. That gives us the concentration now, right, of alcohol once we combine these two things. So what do you think we're going to set this equal to then? Okay, good. 16. So I'm going to write this as 16% because that's the total amount, right, of concentration that I want to end up with. But if you remember, we did 10% times the liters of wine plus 70% times the liters of alcohol solution. That's going to be equal to 16% times the total amount that we actually have. So what are we going to have to multiply 0.16 by? 1,000, right? So just be real careful, right? That's the part that it's easy to leave off. But again, since we're doing concentration times liters plus concentration times liters, we need concentration times liters on the other side also. So those are our two equations, right? And again, if you want to go ahead and multiply what you have on the other side there, we can. So x plus y equals 1,000. And then 0.1x plus 0.7y is equal to, multiplying by 1,000, we move that decimal 3 places, so that's going to give us 160. Any questions just on getting the system for this one now? All right. Now, again, if you want to use Desmos and graph it, perfectly fine. If you want to try elimination or substitution, also perfectly fine. I'm going to do this with matrices again, just to show you the process one more time so that you can get more comfortable with it. So in this case, what are the dimensions going to have to be for the matrix that we're going to use? It's going to be 2 by 3 again, right? So we're going to do another 2 by 3 matrix. And I've got 2 equations, that's my 2 rows. I've got 2 variables and a constant, that's my 3 columns. Now, what's that first row going to look like then for this one? What would those entries be? Good. So first one is 1, that's the coefficient of x. Next one is 1, because that's the coefficient of y. And then 1,000 is my constant. So again, we have our x, we have our y, and we have our constant. What about the next row? Good, right? So 0.1 is the coefficient of x, 0.7 is the coefficient of y, 160 is our constant. Now that we have our matrix, we can go to our calculator. We can find the reduced row echelon form of that. So switch back to my calculator. All right, so again, first step, we're going to go to second matrix, right, or just your matrix key, depending on the calculator you've got. We have to go over to edit so that we can actually input that matrix. Choose whichever matrix you want. I'm just going to overwrite the one that I've got in A for now. Dimensions here again are 2 by 3, so we don't need to really change anything there. Our entries this time from left to right, we have 1, 1, and 1,000. And in the second row, we have 0.1, 0.7, and 160. Now, again, always go back to your home screen next. I'm going to do second quit. And again, the reason for that is if you don't do that step and you go right back into your matrix menu, whatever you select is going to go into your matrix instead. We need our REF on our home screen, not in the matrix. Okay, so that's why you have to do second quit here. And now we do second matrix again. I need to take the reduced row echelon form, so I'm going to go over to math. Scroll all the way down to RREF. I'm going to choose that one. And then I need to tell it which matrix I'm taking the reduced row echelon form of. So go back to your matrix menu. Under names, we choose matrix A. And it's going to give us this. Okay, so now we have 1, 0, 900, 0, 1, 100. Any questions about the steps in the calculator there to get that? All right. So that's what we got. So what does that tell us now? Good. So our X value is 900. Our Y value is 100. And so this is 900 liters of wine and 100 liters of alcohol solution. Okay. And again, same solution you would get if you were to graph it or use substitution or elimination. So whatever method you want to use is perfectly fine. But again, on the word problems, if you want to use the graphing method or the matrices, I'm perfectly fine with that. Otherwise, if I specify use elimination on some of the other problems, just make sure you're using the method that I asked for. Any questions on that one now? All right. So those are the word problems from 10.1. So now I want to do the word problem from 10.2. All right, so here we go. So example 5, again, this is 10.2 now. So Jason receives an inheritance of $50,000. His financial advisor suggests that he invest this in 3 mutual funds: money market fund, blue chip stock fund, high tech stock fund. The advisor estimates the money market fund to return 5% over the next year, blue chip fund 9%, high tech fund 16%. It says Jason wants a total first year return of, I left out that dollar amount, so let me make sure I have that correct before we start. All right, so that should be $4,000 here. All right, so to avoid excessive risk, he decides to invest 3 times as much in the money market fund as in the high-tech stock fund, and we want to know how much he should invest in each of those funds now. Okay, so what are we going to do first here? Good. We need 3 variables because we have 3 different funds that we're investing in, right? So what variables do you want to use for your investments? Okay, X, Y, and Z is fine, right? So X, Y, and Z. All right, so what is X going to represent in this case? All right, that'll be our money market. What are we letting Y be then? The blue chip, okay? And that means that Z has to be the last one, which is our high tech. So this is how much money we're investing in each one of those funds now. Now, if we've got 3 variables, how many equations are we going to have? Right? So we've got to come up with 3 equations to be able to solve for these variables now. So looking at your information here, what's one equation that we could write? So tell me this, how much money is he investing? $50,000, right? He receives that inheritance, he's going to invest it all. Well, if we know that X is the amount he's putting in money market, Y is the amount he's putting in blue chip, Z is how much he's putting in high tech, and his total investment is $50,000, what's an equation I could write here? Exactly, right? If we add up those 3 amounts, it should total $50,000. The amount in X plus the amount in Y plus the amount in Z should equal $50,000 now. So there's our first equation. Right, let's look at these percentages now, right? So just like we did with the mixture problem, how could we write an equation now based off of those percentages? Almost, okay, so just be careful here, right? So 5% instead of 0.5 would actually be 0.05, right? So just make sure you got that extra 0 in there, so 0.05x. Then for the 9%, it's going to be 0.09y. And then for the z, it will be 0.16z. And then we're going to set that equal to what? 4,000. Good, right? That's how much interest we want to earn on all 3 of those accounts combined. So He wants a return of $4,000. We're going to set that equal to 4,000. All right, there's two of our three equations. What else do we know now that's going to help us define that last equation? Okay, good, right? So we need 3 times as much in money market as high tech. What would that equation look like if we want 3 times as much in money market as high tech? Okay, x equals 3z. And that's perfect, right? So it's really easy to mix that up and put the 3 with the x instead. But remember, we need to multiply the amount in high tech by 3 to give us the amount that we have in money market this time. So that's why it's going to be x equals 3 times the amount in the high tech. Any questions about how we got that equation now? All right, now again, whatever method you want to use here to solve is perfectly fine. You could technically say, well, I know x equals 3z and plug that in for the x's, and then you'd have equations in 2 variables, and then you could use elimination. But again, on problems like this, you could use matrices if you want to, because I don't really care once you get the setup how you solve it. If you're going to use matrices on this one, you have to move everything to one side first so that your variables all line up. So this equation right here now would actually be x minus 3z equals 0. Okay, so just remember, if you're going to use matrices, move all the variables to one side first. What would the dimensions be for a matrix if we're going to use matrices on this one? Okay, so almost. We do have 3 rows. How many columns are we going to need, though? We're going to need 4 columns, 3 variables, and the constant, right? So when I set this one up now, it's going to be a 3 by 4. All right, the first row here, I'm just going to list these out. We have coefficients of 1 for all of the variables, so 1, 1, 1, and then 50,000 is our constant. The next row here, we're going to have 0.05, 0.09, 0.16, and then 4,000 is the constant. And then down here now, again, looking at this one, 1 is the coefficient of x. I don't have a y term, so we have to put a 0 in that place. So 0 goes in that column. -3 is the coefficient of z now, so -3. And then 0 is our constant term. So just to remind you right now, the first column is our x's, second is y, third is z, and then we have our constants over here then. Just like with the 2 variable systems, we're still going to do reduced row echelon form. We're just going to input a 3 by 4 matrix this time instead. So again, I'll go through those steps in the calculator with you. All right, so get to your matrix menu, go over to edit. So this time we do need to change our dimensions. We said it's 3 rows and 4 columns, so we have a 3 by 4 matrix instead. That first row, we're going to have 1, 1, 1, 50,000. Our second row, we have 0.05, 0.09, 0.16, and 4,000. And then the last row, we had 1, 0, -3, and 0. All right, now Now that we've got the matrix in there, get back to your home screen, second quit. Now we need our reduced row echelon form. So I'm going to go back to my matrix menu, go over to math, scroll all the way down to RREF, select that one. And again, we need to tell it which matrix we're working with here. I put mine in A again, right? I just changed it to a 3x4, so I'm going to select matrix A again, take the reduced row echelon form of that, and that's what we're going to get. So what does that tell us now about our solution? Good, right? So X is 30,000, Y is 10,000, and Z is also 10,000. And remember, these are amounts of money that we're putting into these stock funds. So now when I write my answer, we've got X equals $30,000, Y equals $10,000, and Z equals $10,000 also. Okay. So in other words, we're putting $30,000 into our money market, $10,000 into the blue chip stock fund, and $10,000 into the high tech stock fund. Okay. And always make sure that your answers make sense, right? We know we had a total investment of 50,000. Those added together does give us 50,000. We know we wanted 3 times as much in money market as our high tech. We have 30,000 in money market. We have 10,000 in high tech, right? So that makes sense. Any questions on that one now? All right. I'm actually going to go ahead and look at 10.8 and try to get through the first example, just so you have an idea if you want to work on that one on your test. And then we'll come back and finish up 10.8 and what we can of 10.9 tomorrow. Okay. All right. So this is 10.8, systems of nonlinear equations. So basically what we're looking at now is, what if we have equations that aren't lines anymore, right? Because everything we've looked at so far, we had x to the first, y to the first, z to the first. Now we're going to look at what if there's equations that have other exponents, right, that aren't lines. So if I'm finding the solutions to this system, we can actually use some of the same methods that we used before. We can only use certain methods on certain problems, though. So we have to be careful. Like this one, we could not use elimination because there's not going to be a way to cancel out the x squares because we don't have an x squared in the second equation. There's not a way to cancel out the y squared because we don't have a y squared in the second equation. So substitution is the only way we could solve this one now. And we can't use matrices because our variables wouldn't line up, right? We have x squared and y squared in the first equation, x and y in the second equation. So if I wanted to use substitution here, I'm going to solve that second equation for y. I'm going to take 3x minus y equals 10. I'm going to solve, so I'm going to move the 3x to the other side. We get negative 3x plus 10. Divide by a negative every term. That's going to give us 3x minus 10 now. Now, just like before, when we substitute, we're plugging that in for y in the other equation now. So I'm going to have x squared plus 3x minus 10 all squared equals 100. Now, what's 3x minus 10 squared going to give us? Okay, so be careful here, right? We have to use FOIL to actually multiply this out. So we're going to have 3x times 3x is going to give us 9x squared. The outer terms are going to give us a negative 30x. The inner terms are going to give us the same thing. And then the last terms are plus 100. So combining like terms there now, we're going to get 9x squared minus 60x plus 100 equals 100. And now we have this quadratic that we can actually solve. So we combine like terms, 10x squared minus 60x. Subtracting 100 from both sides here is just going to give us 0. I know we're out of time, so I'm going to stop there. But just to show you, right, we can use the substitution method on problems like this, just like we did before. We just have to be sure we're using a method that actually works for that particular problem, right? Because not all the methods are going to work if they're nonlinear now. Okay? But again, we'll finish that one out tomorrow. Solve for x, plug it back in to find your y values. And then I'll show you what we know about the types or the number of solutions to problems like this also tomorrow. Okay? All right. So again, just work on your test. Make sure you get that submitted by Friday at midnight. Homework, same thing. The 10.1 to 10.3 homework due Friday by midnight. Let me know if you've got any questions about either one of those things. We'll finish up 10.8 and 10.9 tomorrow, and then Monday and Tuesday of next week will be review. Okay, so if you want to stick around for the review, that's when we're going to review for the final exam. Okay, have a great afternoon, and I will see you all tomorrow.